Morning, everyone. Good morning, everyone. Sorry about that. Good morning, everyone. I am Priyashni Sawant from the GITA team from Forbes Mazars, and with me I have my colleague Vivek Kumar from Forbes Mazars, who has over 22 years of experience in transport logistic consulting. We are delighted to welcome you all to the session of data analytics in transport and logistics. Before we jump into the data and dashboards, I would let me just quickly walk you through the agenda for the next hour and how the flow will go. We will start with why analytics has become a critical in logistics sector. The transport and logistic ecosystem today basically runs on data from toll plazas and GPS systems to warehouses management and ERP transactions. And we'll see why being data driven is now an advantage rather than a luxury. Then we'll move on to understanding what data analytics actually means, the data, different types of analytics, and the tools we usually use. We'll see the terms like descriptive, diagnostic, predictive, and perspective analytics, and how we'll connect them with the tools like Excel and Power BI. The idea is to help you see which tools are right for which level of analysis. The third and the most exciting part will be an hands-on demo using Power BI. This is where we will take a real transaction data that we deal with in real projects and walk through how it's cleaned, modeled, and visualized. We'll see how we turn this raw data into decision-ready insights via using Power BI. This will be a basic introduction to Power BI. I'll talk a little bit more about the Power BI layout, some features about it, and how to figure a way out of in Power BI. Then after that we'll just explore and talk about real world example use cases where we can use our data analytic techniques. We'll draw examples from logistics, ports, and toll operations where analytics has made a huge impact from reducing waiting times to optimizing fleet utilization. Finally, we'll close with career and capability insights and how you can build your strong data skills in consulting in the logistic domain. I'll also uh, help you all from whether you're from the business or the technical background. I'll just share some few practical steps or tools that y'all can which will help your career in start building dashboards or get yourself into the analytical world. So before we begin, I just want to ask a small question, like according to y'all, what do y'all understand by data analytics? And I hope y'all can just answer in the chat whatever y'all think, what is according to y'all data analytics means. And with that, I would like to let's move on to our first topic, why data analytics in logistics, and see how analytics is transforming and how decisions are made in this sector. So let's begin. See, the logistics sector is today is one of the most data intensive industries in the world. So every truck movement, every warehouses transaction, every RFID tag you see, every GSP, GPS ping, they all generate some kind of data. But here's the reality that most companies have the data, but they don't know how to get insights from those data. They have tons of operational data stored in silos, ERP systems, transport logs, and toll records, but very few can convert that data into decisions. That's where data analytics comes in. It basically connects operational data with business outcomes. For example, with analytics, we can forecast freight movement, optimize routes, and even predict warehouse congestions before it happens. Now, each business scenario has its own ROI. For every initiative, we must look at the cost and benefit analysis. And also here at Forwest Mazars, we help clients find that balance through the analytics-driven solutions and improve the efficiency, reduce the cost, and enhance performances. Also, when you look at the pros and cons, it's easy to see why companies are nowadays investing heavily in this area. So on the pro side, analytics drives like cost reduction, efficiency, route optimization, and real-time viability. But on the con side, there are challenges like this huge implementation cost. There is a lot of data security you need to do that, and you need a lot of skilled talent for that. So there is a balance between value and complexity. Now, I would want to explain you through an example. So how data analytics will make logistics smarter. So imagine like a warehousing and trucking operation. So for a logistic player, every day hundreds of trucks are moving between warehouses, some outbound, some inbound. Each vehicle has its own GPS tracking. Every warehouse will have its own logs like due in and due out, timestamps for each shipment. Now, the problem here is that the data sits in different systems. GPS is in one platform, the warehouse data logs are in another platform, and the billings are in Excel. So operation managers have no single view where the delays are happening or which route is most efficient. So now when we bring data analytics into this picture, things starts to change. So by connecting GPS and warehouse transaction data, we can visualize how long trucks spend in transit versus idle time at warehouses. So if a route from Pune to Nasik it's taking a longer time, we can pinpoint whether it's due to a specific choke point or an inefficient loading process at the warehouses. So over time, these insights lead to a smarter scheduling. It can improve your route optimization, even predict maintenance for the fleet, meaning there will be meaningless fewer breakdowns and faster deliveries. So analytics isn't just about the dashboards, it's about the connecting the dots between the systems and turning the data into an intelligent network. That's what we mean by making logistics smarter. Now that we have seen why it matters, and how it helps us solve real world problems and real operational problems. Let's move on to the next section. So let's go just one layer deeper and understand what analytics actually involves and how it adds value across logistics and infrastructure. At its core, data analytics is the discipline of cleaning, transforming, and modeling data to generate patterns that form strategy. Now, in the transport and logistic context, it enables four big outcomes. The first is I'm sorry about that. First is problem solving. The logistics operations are complex. Uh, Logistic operations are complex. Thousands of moving assets are there. There are multiple stakeholders. There are tight timelines. So when something breaks, a shipment delay, a congestion at a port, or a mismatch in dispatch volumes, analytics will help trace the root cause of it. Then it helps in trend identification. So when logistic data has a strong seasonal and temporal behavior, traffic volumes basically when if they're peaking before festive months, warehousing utilization fluctuates within the production cycle, if you can say. The freight rates vary by the corridor and the commodity. By analyzing this historical data month over month, or you can say year over year, we can identify recurring trends that influence the future planning. And using trend identification, we can make decisions, informed decisions. Like this is where truly analytics becomes transformative. Think of like example, a transport planner who must allocate trucks across 5 states. Now, without analytics, they rely basically on their intuitions and last month's excess summaries. With analytics, they can simulate what happens if they shift 10% of capacity from low performing routes to high demand ones. And this you can see you can see the effect on the cost and the service impact. So similarly, infrastructure agencies can compare performance across toll plazas or posts using KPIs like revenues per lane, vehicle throughput, or congestion ratio to decide whether the investment or process change will yield the highest ROI or not. In short, it's about replacing guesswork with evidence. Now, the fourth is effective communication. Now, this is also very important because once you have your dashboards, you have your visualization, you have done the analysis, but it is very important to communicate this to the stakeholders for to communicate the story, communicate the decision or the data what you have removed from the analysis to the stakeholders, whether it's a port chairman or a logistics CFO or a government agency that can understand the whole, visualize the whole process in within seconds. For example, if you see a single heat map is showing like a peak congestion hours or a variance chart tracking daily collections that can communicate an operational risk far more effectively than a 20-page report. So this is where Power BI comes in or Excel comes in, and this is they doesn't calculate, they will communicate the data to you all. Now that we have seen that data analytics means it's in broad sense cleaning, transforming, and modeling data, let's break it down into 4 levels. There are 4 types of data analytics. First is descriptive analytics, like what happened. This is where we collect our historical data and quantify what has occurred. So, for example, a toll operator must be using might use descriptive analytics to show that the toll collections for quarter were, for example, rupees 420 crores, up to 12% year on year. This answers a factual question, the basically your counts, your totals, your averages. And Excel dashboards and pivot tables are perfect for this stage. But while it tells us what happened, it doesn't tell us it doesn't tell us why. So this is where diagnostic analytics comes in. Here we start connecting causes. Suppose the same toll plaza sees a revenue dip in July. Now, diagnostic analytics will help us trace the reasons. Maybe it might be because of monsoon-related road closures, fewer heavy vehicles on that road, or there's an ERP downtime. So we use these correlations, drill downs, and root cause analysis to move the raw observation into an explanation. It's like you are being a detective with the data that gives you clues, and your job is to basically connect them. And once we know why something happens, we can begin forecasting it. So this is predictive analytics comes in. Basically, they use statistical models or machine learning to estimate what's likely next. In logistics, this could mean forecasting a truck arrival at a warehouse based on the past shipment data, or projecting a toll traffic on the Mumbai-Pune corridor up for the upcoming festive months. Now, and finally, the most advanced stage is perspective analytics. This goes basically beyond your prediction or recommendation. It's like, what should we do about it? In this stage, the system will itself suggest some actions or outcomes. For example, it may recommend doing an extra toll lane during peak hours to reduce waiting time. So while descriptive analytics only collects and shows the data, and the rest is up to the human intelligence to figure out what should we do about the data. Perspective analytics will tell you, will predict the outcome, will recommend the best possible action also. So I would like to ask you all a question. So a port authority wants a recommendation on how to reduce waiting time at gates. Which type of analytics fits the best? You all can just answer. These are the options like perspective, diagnostic, predictive, or descriptive. You all can answer the question in the chat. Most of you all are answering right, like it's D, correct? It's perspective analytics. I can, for instance, so when it says Port Authority wants to reduce the waiting time at entry gates, a perspective analytics is like, what if we open one extra gate during peak hours, or what if we reschedule container loading? So it basically, it doesn't just forecast. It basically, it will give you an outcome of this. So here, perspective analytics fits the best for this question.
Yeah. So just to add to this point, now when we are talking about different type of analytics, what is going on under the hood, right? What is the analysis we are doing? What is the analytics actually about? So generally, you may be using a lot of different mathematical, logical, statistical operations across all of them, but there are certain types which are more suited to a specific category. For instance, when you say descriptive analysis, right? What would your typical things be? So what are we using typically? One is your your mathematical operations, which is subtraction, addition, multiplication, division, statistics of mean, median, mode, correlation, variance analysis, regression, etc. Right? So in your descriptive analysis, you're basically describing the data. So if anybody has used statistical packages, there is a separate section called as descriptive analysis typically there. Now there, what we would use, you would use things like what is the total sum, describe the whole scene, right? Describe the population, the data, the sample, or the population data you have. So you'll use things like total sum by category, or other your mean, median, modes, your normal distribution, standard deviation. Those are the typical terms or logical operations in which you would use to describe a certain set of data. Coming to when coming to diagnostic analysis, what is typically that you would do? You would look at what is the idea? You see, versus the expectation, what is a reality? Therefore, a lot of diagnostic analysis will be variance analysis. It would be simple x minus y, budget minus actual, or projected minus actual. You would do some kind of a covariance analysis, maybe also get into saying what is the reason for it. So a Pareto analysis or things of that sort could also happen there. When you're looking at predictive analysis, you're basically forecasting basis what? Basis the historical data pattern. And therefore, to understand the data pattern, which is what is the relation between one variable versus other, you generally would look at a correlation regression kind of analysis, and then use that same logic to extend up, going forward. So it might be a simple relationship like y is equal to a plus x kind of relationship, or it could be a more complex relationship. Those of you into statistics or understand maths or interest there, typically you would have equations, and those would also get presented in the visual format. So a lot of times understanding the relationship is difficult. If you have worked on, say, for instance, a regression equation, it could get into complex, long complex equation could happen there, but a visual representation of that is easier to interpret. However, when you're doing those analysis, you'll also have to do those analytics, those logical operations. When you're doing prescriptive analysis, as I was talking about, what do you actually do? You're saying recommendation of action, which means what? There are options. If there are no options, there is no need for recommendation. So the recommendation for action, which is choosing option A versus choosing option B, right? Now, the way you would go about it is basically saying, okay, a tool which you typically use is what was called as a scenario analysis. If scenario 1 the setting could be A, B, C. In scenario 2, the setting could be D, E, F. In those two outputs, what is the outcome? And where does this, how do you get those outcomes? It's basis the first. So prescriptive analysis will not happen independent of separate of other analysis. Most often when you're doing your analysis, it will start from a descriptive analysis, You will build some predictive model into it and then utilize it to do a prescriptive analysis. A lot of this has been made very, quite easy by using AI. A lot of relationship between data, analysis of data, AI is able to do much better. There are other things like, obviously, your machine learning and so on, where large sample of data is analyzed much better. Then there are things like statistical model, which you build in and so on. All of this comes under the ambit of data analytics sometimes, and all of it is in some way or the other also used in logistics. So over to you, Priya.
Yeah, thank you, sir. I saw one question in the chat. Like, I hope Vivek sir has answered your question to elaborate the predictive analysis more. Moving on.
Can we just, what is the question?
So I think one person was asking to elaborate the more on predictive analysis.
In a way, yes. See, your diagnostic is about past, but it's not totally past, because it would mean, the same relationship, the same problem, the same issue, and the same data pattern could continue in the future as well. So diagnostic is more about understanding basis the past data. Predictive, why we are not using the past future kind of thing. I mean, in all cases, you're using the past data to predict the future. So while the ambit of diagnostic kind of remains in the past, or even descriptive remains in the past, and prescriptive is more future oriented, it is not as if, there is a definite time, categorization of past and future here. Why is the case of waiting time? Yeah, so it will be a diagnostic analysis as well. But see, what is the question? The question is recommendation, right? So you would diagnose and say what? You'll say, okay, there is long waiting time because there are more trucks in the line at that time. And the speed of processing is less than the speed of, entry of trucks. So that diagnosis is there, but then to do what? Is what your prescriptive analysis will say. You would also use a predictive analysis to say, okay, if I open another gate, or if I reschedule my operations, or if I say add another resource, for instance, okay, or maybe I do a pre-processing in some way if it's possible. So all of those are possibilities, scenarios which you would use, and then at the end of the day you have to give a prescription saying, do something, do A or do B, and this is the cost and the benefit of doing A or B. Diagnostic is not this mostly making the data readable, it's understanding why the problem is. A lot of data we get is a data which is what is called as the the lag data, right? I mean, it's after the process has happened, that's what we are getting, the output. But why it is coming, that's the purpose of diagnostic analysis, is to understand why something is happening as the way it is happening. So Ankur, Abneesh, Swati, Shweta, have I answered your question? Any further clarification here? My sense is, I mean, why this categorization helps, right? When you're saying descriptive to prescriptive, it gives you an understanding of what data analysis you have to do. Possibly the tools you use is the same. So when you're doing a prescriptive analysis, say you're doing a cost benefit analysis in a prescription scenario, you'll say, benefit minus cost, is it positive or not, right? And then you'll say develop a different scenario and say, okay, by order, scenario 2 is better among the lot, right? So similar simple subtraction you'll also do in a diagnostic analysis, right? So the operations may be similar, but the purpose is different, and which is why we have different categories. And sometimes when you're doing prescriptive analysis, what also happens is that you may not have all the data, and therefore, all the required data, because you're looking into future, and future patterns may not necessarily be a repeat of the historical patterns. So there are certain projections, certain estimations, certain assumptions which you'll have to do. Therefore, prescriptive analysis becomes trickier. Okay.
Yeah. So I think we can move on. So now this slide basically summarizes the entire journey of how analytics, from asking the right questions to finally integrating the technologies for the smarter decision making. But we would like to focus mainly on these three critical stages that actually shape the and impact any data project. So first is establishing the questions, right questions. So which every analysis begins not with the data, but with a question. So in consulting, we call this a hypothesis driven approach. So before we even look at the numbers, we want to ask what do you want to prove or disapprove. Now, for example, for instance, in a logistic project, we might begin with questions like which toll plazas contribute the highest delays in vehicle throughput. Can a route optimization improve delivery time without increasing fuel costs? So the first step is about defining the objectives for the analysis and understanding what business decisions will this data support. And once that is set, then every step after that is like to collect the data, then you review the data, you clean the data, you model the data, aligns with the purpose, with this purpose. So, and then after we have collected the data, cleaned the data, refined, model, we move on to the visualization part of it, where the data basically turns into an insight. Visualization helps us see what raw numbers are trying to say. For example, a trend line can instantly show you all how the seasonal peaks are happening in a toll collection or a warehouse dispatch volumes. A heat map can highlight areas with congestion or delays. A box and a whisker plot can show revenue outliers, plazas performing. So, for example, in a data, if a toll plaza is just performing 50 lakh rupees and one is doing 5 crores, that's an outlier. So, box and a whisker plot will help you identify that particular outlier. So when visualizing the data is basically choosing the right graph, which makes the difference. So like line graphs are basically to show trends over time. Bar charts basically compare categories. Pie charts are to show proportions. Maps visualizes the geographic spread across the data. Then the key is the visualization should make a story self-explanatory. A good chart doesn't just show the numbers, it basically answers the question. And in Power BI, that's where we see the power. One click and you can filter the entire dashboard by state, month, or toll category. And you can reveal patterns that you would never spot in an Excel spreadsheet. So the next point is building a narrative. Now, once the insights are visualized, the next step is always building a narrative. That is basically creating a story that ties this data together. So a narrative will turn those data points into a business and intelligence. So it answers, so what? Now, for instance, your analysis might show a collection in Gujarat are 15% higher during March and October. The story out of this could be this aligns well with the industrial production cycles, suggesting that the logistic resources need to be reallocated during these months to handle higher traffic volumes. See the difference? Now, the first is data, the second is a decision insight. So this is where, to summarize, we start with a clear question, we visualize the data to find the answer, and we build a narrative that derives the action. And now, I think Vivek, I would over to Vivek, sir.
So let's look at a certain points here. When we talk about establishing questions, what are the questions which we need and require in this context, right? Like Priya talked about, a hypothesis, setting up a hypothesis is one way of looking at, doing that step. Now, those questions have to be relevant to the business. In logistics, typically you look at, your speed of movement, your cost per unit, your total cost, your variance over period of time, components of costs, components of revenue by, which category is contributing more, where are the typical bottlenecks. So these are the questions you will have. These questions will come from the business sense. Now, why are we emphasizing on this point? One, data analytics is, there are two parts of it. One is the technique and the tools and the techniques. Those, for those, you have a lot of tools which are available. Power BI being one. You can use Python if you want to, if you're familiar with that. You can use other tools. There are, statistical tools which are available. AI, a lot of AI tools are now available. Excel is obviously there. So these options, there are tools and techniques which are there. Establishing question is a thing where, sometimes AI may be helpful, experience may be helpful, but it requires a certain level of thinking. So, for instance, in your roles, I'm assuming a lot of you are in the, in initial years of a career. When a question is asked, when you are asked to do something, ask a few clarificatory questions on that. Okay, what does it mean? Why are we doing it? So what else, etc., etc. So it helps you expand the scope in the right direction. Sometimes if you don't have the right question, your analysis will go in the raw direction itself, right? So remember, there's this concept which is talked about. There's a thing called garbage in, garbage out. So if you have the wrong direction, wrong output, something like that happens in analytics as well as another case as well. So one needs to be relevant, aware about that. In logistics, your typical questions would be what? Okay, so like, the instance which we have talked about, what is my cost, say in Gujarat versus what is my cost in Maharashtra? Say it could be warehousing, operation cost. Say for instance, what is the turnaround time for ships at a port? What is the turnaround time for a, the process end-to-end cycle time for a container movement within the port? What is the dwell time at a certain, container station or something of those sort? How has it changed? Quarter-on-quarter variation, month-on-month variation, trip-on-trip variation. How is it varying? What is the range? Where, what percentages, or what percent, how compliant are with our promises or with our targets? So those could be the questions which you would want. That's one. Second, when you're building a narrative, what is narrative basically coming out of? Narrative is basically in a way, a nice story which fits in your data and analysis and your outcomes. In your narrative, there would be something, there would be a lot of, your narrative will be coming out of a lot of inferences. What are the inferences? You're saying, okay, of all the data, for instance, the data we look at, toll plaza. Okay, average toll collection per toll is X amount. Right? Average toll collection per type of vehicle is so. So these are multiple inferences which you will possibly have. For instance, in a warehouse operations, you will have things like, okay, average dwell time is this. The average processing time, from order to delivery, or in order to loading is so much, right? Which could also be broken down into different sections. Now, the insight is basically a combination of inferences, saying if for certain types of data, it becomes a problem. This is, when you do aggregation, for instance, in a warehouse, typically, locating large items is not a challenge, but locating small items could be a challenge. When you have, a single order, single piece order, it may not be difficult. When you have order which is, let's say, boxes of commodities, it's not a problem. When you have to do mixing, for instance, that's a problem, or that's a challenge. That's where, processing is involved. Most steps are involved. So there, how insights are built in. Your data analytics helps in a great sense in doing those analytics. And sometimes when you're doing this analysis, see a change which has happened from earlier versus now is that now we are collecting a lot of data. Second, the data computing ability is much higher, right? It's much faster. You have tools to do that. So use the tool appropriately to do some extended analysis. Add a few steps, look at different perspective. Earlier, over when it was a simple Excel, possibly it was not as easy. Now with the Power BI or Tableau or other tools, the visualization becomes much easier. The analysis becomes much easier. Sometimes you don't even need to know the formula. You don't even need to know the process. You basically ask a question and the analysis happens. So those are, from a input from your perspective, from your role perspective, from your responsibility perspective, when you're building your narrative, when you're doing this data analysis, do keep a higher thought, give a higher thought to establishing the right question and building the right narrative. When building the narrative, also it's important to understand the role of validation. If your data is saying something and you have come to a certain insight, go back and check whether it's the same thing or not. It's the idea of hypothesis testing, is basically saying, okay, so what is the probability that my answer is correct? That if you are able to understand where it is going wrong, then your narrative or your storyline, your conclusions will be much more robust. Don't jump to the first conclusion that you get on two things. Validate that. That's an important thing. So that's my 2 bit here. Priya, over to you.
Thank you, Vivek sir. And now that we have understood how data analytics works, let us bring it to life with a real example. So we'll do a mini exercise where we'll be using a FASTag toll data. So it's the same type of data which is collected daily at toll plazas across India. So the step by step, I will take you through the flow. We'll start by looking at our data source and first I'll let you know why we have chosen this data. So toll data for this demo is basically, it's very structured and it's collected daily across thousands of plazas. So which is basically, it makes it perfect to analyze trends, identifies patterns, and link any operational activity to the revenue. So this also, I just want to touch upon one point here. What is structured data and unstructured data? So structured data is like what we see here is like organized neatly in rows, columns such as Excel sheets, your SQL database or your CSV files. But unstructured data, on the other hand, can include items like your weather data, your GPS, or your PDF reports. Basically, they are rich in information and a lot of data, but not easily analyzed without without using special tools. For this session, we will focus on the structured toll data. And I would like to just hold a disclaimer. This data set is incomplete. I'm just using from the months of January to August. So the trends or whatever patterns we see is solely based on that. And this is only to show you all how we can go through Power BI and just show some features of Power BI and how we can do cleaning over there and how we can make graphs, visualize the data, and make the dashboard using this. So first we're going to, the steps to analyze the data is like, first we import the data. So first I will take you all through the steps. First we load the data into Power BI. Then we have to ensure it's clean. We open the Power Query and clean the data. Then we organize, then we build a data model around it, and then we visualize it. So I will take you all through each and every step of this process. The first is the raw data. So I just want to show you all how our data looked like before. So I had got this toll data from the EPS website. So there were two sets of data. One was the monthly data from Jan to August in different sets of PDFs, where you had your plaza name, you had your car, Jeep, type of vehicle with the collection and the amount, collection and the count, how many times the particular vehicle has passed through that toll plaza. And the second set of data which we had was just basically your your plaza name corresponding with in which state it was, which district, and the section of highway. For this toll data, I have since I've concentrated on the Mumbai-Delhi corridor, so the NH48 and NH8 are the highways which I have selected for this data, because the toll data is more than 1,000 rows, and to clean it, and it is very to do it in Excel, it will take a lot of time. So here Power BI comes in. Here you can upload multiple Excel files, you can append them, and you can update the data constantly every month as new data comes, and update your dashboard. This is where Power BI is very at a huge or larger advantage than in Excel. So before we start, I would tell you all, let's open the Power BI desktop, and I'll just switch to my Power BI screen, and let me know if you all can see my screen. Yeah, okay. So this is whenever you are open to download the Power BI desktop is easy. Just go to your Microsoft Office and you can just download your Power BI desktop from there. So the desktop version is, this is the workspace. This is where we'll build, clean, and design our dashboard. This is your report view basically. Here is where in the visualization pane, you can see there are a lot of graphs which you can just select and you can build a visual out of it. Data is where all your tables will be there. Once you have imported, once you have cleaned, and once you have transformed them and made a model out of it, then in this data tab, you will see these tables come. Here, I would also want to say that once we have done the report, we have made our dashboard, you can see this publish. It's when you publish it, it takes you to the Power BI Cloud. Now, Power BI Cloud is basically where you can share and collaborate with your colleagues, and you can keep on updating the data over there, the dashboard over there. And the advantage, I think, is free for a couple of for a couple of days, and then it becomes the paid version. But the desktop version is where you can learn, you can get familiarized with this, how you can build visuals, and here it's free and it's a huge learning process. And also then in the help section, there are a lot of learnings, training videos and everything which you can, if you're stuck somewhere, it is a huge help to operate this on Power BI. Now I would like to just take you all through some tabs to just make you all understand some major tabs which we'll need to initial steps to understand the clean the data. First, you see get data. Here is where you will import your data. There are many like from your Excel, CSV, your SQL Server, your SharePoint, OneDrive, web APIs. You can import your data from here. So when I click here, for example, if I click on this get data thing, if you can see, yeah, you see you can import from an Excel workbook, and you can just connect it. So when you connect the Excel your data, it leads you to an option called transformation data. This is where this tab is basically your Power Query. So when you transform the data, it will take you to a Power Query where you will clean your data, you will remove any missing value, you will add some columns if you want, which is related to your model, and then you can just close and apply, and which will take you to your data model. This is basically your data model tab where you can see how your tables are working, what kind of relationships each table has with each table, and how you can manage the relationships is for this. If there is an error with a primary key or a foreign key and the tables are not connecting properly, here you can click on manage relationships and you can edit the relationships or add a new relationship to it. You can add new measures. Now, new measures is basically your DAX expressions, like your Excel calculation, what you all do, like total sum amount. You can, if you want to calculate the total amount for entire toll revenue, so you click on a new measure, you put a formula, and then a measure is formed. Like if you can see here, discount by a vehicle, these are all measures. And you can add a new table. Like here, I didn't need to go into my Excel file, add a calendar table over there, add my dates over there, and then import it. You don't need to do that. You can directly add a new table here. You can configure your date, your month, your number, and connect this calendar table to your main factual table where your toll plazas, all your data is there. So I would also, now I would like you all to take you all to the cleaning part of it. So when you go to transform, I'll just show you all my transformation window. So when you go to your transformation window, this is basically your Power Query. Here I'm going to see, if you see, this is once for the dashboard which I've already created for this exercise. This is the clean data which I've already done. These are the steps I applied into cleaning the data. Now the best part of Power BI is that in case you have some error or you missed a step, or you think there is the cleaning thing has gone wrong, like you want to retrace your steps, you can just see, this is like your logs, what you all have done till now, your applied step. So you can just see, okay, you want to just go, you can just check that part like this. Okay, you've done this. I've gone to pivot it. I've pivoted some columns over here, and you can go back to, and I added custom lines, like added a column over here. So you can just go retrace your steps. You can cancel, delete those steps if you don't want to do that. This is where Power BI comes in very handy. Now I will go to raw data. This is, I made a copy of my fact clean data, duplicate for this demo purpose, and I'm going to show you all how to do 5 little bit cleaning steps, which is very helpful. So when you see here, whenever you import your Excel file into the Power Query, you're always, your row number 1 is your header names, which is probably your headers in the Excel table. Now, first and most important step is to convert them into your headers. So there is a simple option over here, used first row as your headers. So when you just do that, your first rows are now promoted as an header. Now I'll just go through the data. So there is your plaza name, there's your state, your district, and there is the car jeep count and car jeep amount for each month. So there was a January month, February month till August, like that. Now what, we don't want it like that. We want the matrix to be different. We want car jeep vehicle type should be one column. There should be one column for count and one column for amount. So, for this vehicle, this was the collection it took. For this vehicle, this was the amount of times it has passed through that plaza, corresponding plaza. So, and also we don't need this column. So we can just easily remove this column. So once that is done, now if you want to make sure that if you want to split the column, like car jeep has to be 1 and count should be 1, then the thing is you have to always unpivot them. So here you select all your static columns. These are your static columns: district, section, national highway, and you just right click it and you unpivot other columns. So you keep these columns as it is and you only unpivot the columns which you have not selected. So when you do that, you can see here there are two things which have come, two columns. One is attribute and one is value. Now every car jeep counts, that is that value for it. Every car jeep amount has that particular value to it. Now if you want to, now this is also not helpful because we want the count and amount to be separate. So first we select the attribute value. We want car jeep to have its own metric, and against that there should be count and amount. So we select that. That is where you split the column. So in transform tab, as you see, there's a thing called split column. Now when you split the column, we select the column, then you split it by delimiter. Now this will basically split at each occurrence. So now we have an underscore. So it is car jeep underscore jeep underscore count. So we want to split it. So we want our car jeep to be one column and underscore count to be another. We will split it by the rightmost delimiter, and we just do OK. Now, as you see, now each car jeep has its own count. Car jeep has amount. So this can be, you can just rename it to a vehicle type. This is be your vehicle type. This will be your matrix, if you can see. And also remember each, now if you, yeah, so this is how you can split, you can unpivot the columns and you can make sure your data is proper. Now, if you see your value, there are some are in whole numbers, there is some commas in between. That's the problem for data type. So here in Power BI, if you see ABC and 1, 2, 3, that is where you can change your data type. You can easily select that and you can make it a decimal number. So everything or a whole number or whatever you want, and you can change that data type. Always make sure that the data type is right. So for vehicle type, it's a text, it's right. For matrix, it is a text, that is right. And you can see after every month, there's a total comes here. We don't need that total because then when you visualize it, in the graphs also the total will come, and then that basically hampers with your insights and visuals. So we should always filter, so we can just filter it easily. We just filter it, remove the total. So now once the total is gone, yeah. So here we have filtered the rows. So these are, as you see, these are the steps we have taken. Yes, I have gone a little more deep in the cleaning part for my dashboard, but there I've used some Power Queries also. So if you want to add a column, there is examples, like there's a custom column. So when you click on custom column, you can just put a formula. You want total amount for each thing, or a high revenue thing. Like, so for example, if it is the revenue for this particular toll plaza is more than 50 lakh, then it should be a high, it should say it's high revenue plaza. So you have to do a if statement over here. You name the column name and you do okay. I can just show you all how it will look. See here. So there's a high revenue plaza, but this didn't work because I faced some error during the formula. So you have to always make sure. So since there's an error, you can see there's an error. So you click on that error, you go and you fix it. But right now we don't want to, I don't want to get into the more advanced level of this. I'm just showing you all the basic cleaning steps and everything. So once we have cleaned the data and it will look like my Factol Plaza, we go to home tab, we close and apply. So when you're
Priya,
when you
just 1 second.
yeah.
If I may just add a 1 point. So whenever you're looking at transforming data, see there is this one very interesting thing one to note. If you look at the bottom left, right, it says column profiling based on top 1,000, right? Now even in Power BI, so this particular Power Query is something you'll have in Excel as well, right? The thing is, if you have working with a data set which is very large, say suppose getting into say lakhs and millions of rows and so on, which is a possibility because in logistics there is a lot of transactional data which happens, right? In a parcel truck, for instance, there might be a 20-ton truck might have say 1,000 parcels. So do the multiplication using number of in a full year, how many of them will be there? You have to be careful that when you're doing your transformation, you're doing it properly. One way of doing that is before you get into the data cleaning activity itself, understand the data, which is how you do. What do you mean by understand the data? What is the structure of the data, right? Which means what are the tables which you have, right? What are the columns within the table? What are the categories which are there? Where is the data coming from? What is excluded? What is not excluded? What are the typical formats? So generally, if you see, I mean, if you step back and see where is the data, how is the data being collected, you'll get a sense of it. A lot of times in logistics, the same data set is getting repeated at multiple times. The challenge also happens when it's get repeated at multiple times. There are some variations there. So before getting into the detailed transformation, understand your data. Sometimes there are data outliers, for instance, right? Which you can do like you can do a simple say sorting to understand that. Some numbers sometimes will be very high. For instance, what may happen when you're doing say you're trying to analyze your cost per kilometer for a truck movement. Okay, you will see that when you're doing your visualization will also kind of give you an idea that for say 50 kilometers you are charging 5,000 rupees. For 100 kilometers you are charging 5,500 rupees. Okay, there will be certain instances where you are providing, you may have provided, say as a truck operator, and you have provided trucks on an urgent emergency basis. There, for the same trip, your realization might be 25,000 as well. Now, if you're doing an average using all data, your average will be skewed because of certain data sets. So you need to understand, have a business perspective. Rather than just being a data analyst, you need also to have a, be a business, have a business analyst perspective as to what data is. Do we need to include all data sets? Do we need to segregate it? Do we need to normalize it? Do we need to further label it? Like, what we are labeled, right? High revenue, high traffic. For instance, in this data, there may be, how would you look at categorization? Is it when you say high revenue, is it high revenue in urban context? Is it a toll plaza which is, say, next to the city? Or is it a toll plaza which is, say, next to a port, right? So both may be high revenue, but both will have different contributors. In a port, a toll plaza next to the port gate will have a lot of truck movement. In urban context, somebody like, for instance, the Vashi toll plaza, if you know, in Mumbai, or your Gurgaon, Delhi Gurgaon, mein Gurgaon wala the plaza, right? So those would have a lot of urban, four-wheeler passenger traffic. So understanding that helps in data transformation. It's not just a matter of applying some tools. Yeah, over to you.
Yeah. So as Sir said, also one additional point I would want to say, like, for the toll plaza data, what we had occurred, one major error was that some issues what I faced personally was some plazas, the name didn't match with the other table. So for example, I showed you all in the start that we had used two data sets. One was just the plaza names and other was the plaza name with the vehicle type. Now the problem with both the tables data sets was the plaza name, the spellings. Like when I would be in another place, or there would be I missing or something. So the plaza name would look the same, but they would not match because one letter is missing or so. So that is the issue we face. And to do that manually in Excel is a lot if there is more than 1,000 rows or lakh rows and everything. So here in Power BI, if you see advanced editor, it's like this is where your DAX will come in play. This is where you will put your formulas. This is where you can actually just code basically all your cleaning steps. And then you say, okay, you can run it. And then automatically all these applied steps, which we have seen here, can happen through this advanced editor. So once you put your code, you would say, okay, and then the final product will be this. And then also the advantage is like, if now I have done till August month. So now if I want to get the September month or the October month, I just have to load that Excel sheet in my transformation data. And I just have to run through the cleaning process because you have already established a cleaning process to it. So you just have to run through it once and the data will be cleaned and added over here. And this data will then be added to your data model, which you can just refresh the table and your dashboard will reflect with new numbers there. This is how it happens. And here, once you've cleaned the data, because you can just close and apply. And once you close and apply, it automatically will close your Power Query and it will take you back to your Power BI landing page. And here right now I'm just closing the window because I don't want to apply the raw data clean because I've already cleaned the data for my dashboard and I don't want it to hamper with my dashboard data. So now
I will also talk about the primary, secondary key.
Yeah. So I'm getting into the major thing as Sir had said, what is a data structure to our Power BI thing. So here, if you see, this is our core structure. Now we have a fact toll plaza I've created. This is our main transaction table. This is where amounts, your district, where I've done a lot of, I've added measures like percentile, amount by vehicle, amount mean. I've done some calculations over here. This is where your table stores your measurable data such as toll amount, total vehicle count, and your monthly KPI. And around that, if you see dim vehicle type, your dim toll plaza, your calendar are these dimension tables. So dim toll plazas basically contains your descriptive details about each toll plaza, like your name, your state, district, and highway section. I have created a hierarchy to it. So for example, what does location hierarchy will do? So your plaza name is there, that is your, for example, your state. And then your state say is connected to your district, and your district is connected to your plaza name. So it will, when you visualize it, you basically drill down that through those data. So I'll show, it will be much better when I show you all the visualization process using this hierarchy. And then there's a calendar vehicle type is just basically your vehicle category and your type of vehicle. And then there's a calendar table, which I created, as I said in the beginning. I created in Power BI a new table. I didn't need to import it. Here, it basically handles all your date related logic for your monthly, yearly, or year to date analysis. So together we see this is a schema which has been formed, which is an ideal structure for your analytics. It's clean, scalable, and makes querying fast. Like you don't need to then, if you just have one table, for example, this is our main table, and you don't have these schemas, you don't have a primary key or a foreign key, then every time you get a news data, like new monthly data, it becomes hard to add that data into your structure. And then this is like a time consuming process, then it becomes, which I had faced when when I started with my learning of Power BI. That's the mistakes I had done. And now you have to always have a clean structured data before you get into your analysis. Now, if you see what's a primary key, is basically your unique field that identifies every record table. So in dim toll plaza, if you see, the field plaza name is the primary key, which is connected to through this arrow to your factoid plaza. Now this is one-to-many relationship. How you know? Because here it is one, which is free plaza is connected. So you can, if you click on that arrow, you can see the free plaza is connected one to many to the factoid plaza. So in same way goes to in dim vehicle type. Your vehicle type, if you click on this, your vehicle type is your primary key, which has been connected to your factoid plaza's vehicle type. It's again a one to many type. There's a direction of the arrow defines your relationship with that table, whether the dimension table is what kind of relationship it is, in which direction the relationship is. And same goes for the calendar table. You can see the date is connected to the month date over here. So these are so this now these the sum columns, plaza name, vehicle type, and date also exist in the fact plaza name, but here also there are some things called foreign key, because they reference your primary keys from the respective dimension tables. So essentially the primary key is the identifier in the dimension table, and the foreign key is the matching field in the fact table that creates that relationship. So every relationship in this model follows one-to-many structure. That means one plaza in dim toll plaza connects to many records in a fact toll plaza. One vehicle type in dim vehicle type connects to many rows in the fact table, and one date in the calendar table links to multiple transactions. So if you close, as I said, you can see this filtered arrow is the direction. Typically, if you think that there's an error, and Power BI automatically can detect the connection, you don't need to think which is the primary key. Once you say, if you want to do free plaza name to free plaza key here, you have to connect that, the Power BI will automatically detect a relationship for you all. And if you face an error through that, then you can just go to manage relationship and understand. You can delete that relationship, or you can add a new relationship through that. This is your basically your data model view in your Power BI. And if you go to the table view, here are your particular tables of all your tables which we have showed in the data model view. This is your dim vehicle type, your toll plazas, your calendars. This is your fact toll plazas. So here, if you see calendars, I have I have put this formula. What I've said, for every calendar from this date to this date, there is a year, there's a month number, and there's a year month. So just give me the column. So then, the calendar table and the time has come like that. Then after you have done all of this, the final step here is to make your visualization. So I'll just show an overview first. So here, this is like a basic dashboard. I have not gone into the aesthetic of a dashboard, but you can be creative and how you want your dashboard to look like. Here, if you see, it's a Delhi Bombay corridor. I've added a slicer over here, two slicers. So you can select, if I select Delhi, so it will take you to Delhi. There's one toll, IG Toll Plaza, and I know what is the revenue it is taking, what is the vehicle count over there, what is the average revenue per vehicle, and revenue per toll plaza you can get. If you want to go to, suppose, Gujarat, when you go to Gujarat, you can see the map will take you to, this is that area, and there are these toll plazas over here. Again, tells you the total revenue. So with a single click, you can uh, filter your dashboard, and all your dashboard is connected to all your pages. So there I have created a state page where, according to the state, according to traffic versus revenue per state, I have done like that. I've done the monthly toll revenue contribution by the state, month on month average I have done. So, and you go to a plaza deep dive, is go more into depth with the particular plaza. Like for IG, suppose if I select Gujarat here, for this toll plaza, what was the toll revenue? What is the plaza level for IG toll plaza? Is, if you see, is like 300 is the amount, and this is the highway. This is the location. What is this? This is the location where it is. So this is how you can easily guide yourself to Power BI. I'll just by visualization. I'll just show you all some visualizations and how to go about it. So now that let's us build some visualization. So now let's build some KPI cards first. So there is this in the visualization pane. Here, what you do is basically you can just add your graph. If you want the stack graph, you add a graph. If you want a tree map, depends on what you want to show to the stakeholders, what graph is valid to your data. This is how you have to decide. So for example, I want to now show a KPI card. I'll show this card. You just attach. Now, when you go down, you just have to add your field here. It will to show in my fact toll plaza, I have created a measure called total amount for revenue for all across all plazas. So I just do, it's basically your sum total. So then you just drag it, you drop it, and that KPI card is created. And then you can, in format, you can visually make it more appealing. You can add a title to it. You can create change, make sure the data format is right, the currency is right, in like that. So this is one KPI card. Now I was talking about drill through. What is a drill through using location hierarchy? So I'll just explain that. So if I have a bar chart, for example, let's do a clustered column chart. Yeah. Now I'm just showing you, for example. Yeah, this is your clustered column chart. In your x-axis, I will put, for example, I had your total amount. Yeah, I think I'll put total amount. Sorry, your location hierarchy was in your vehicle type. In your toll plaza, sorry. So here in your local, you put your location hierarchy, and on your y-axis, you just put your total amount, which is your revenue basically. No, wait. So now if you see total amount by state, so basically saying total revenue by the state. So in Delhi, there is this amount of revenue. And when you click on it, you can see the total revenue over here. Rajasthan has this amount of total revenue for the particular months of January to August. Now, what do you mean by drill through? Now, because of this location hierarchy, which I have done, if you see here, the location hierarchy, like it will go through your state. Now you're seeing a state. Now you see these arrows, it will go to a next level of your hierarchy. So the next level is your district. So when you click on it, it will now show your district level revenue. So according to these district where your toll plazas are there, this is the amount it is creating. These are the revenue it is generating for those particular district. Now if you want to step in, go to a next level, you want to check which plaza is generating what amount of revenue. You will go drill through it more and you will see that there are these plazas, toll plaza names, and for that each revenue for that. So when you click on that bar, you can easily see the plaza name and the amount for that. This is how a drill through and a location hierarchy actually helps to visualize and give you more insights to the data. So then also there is maps. So like in the dashboard, I had showed you all how to do a map. So there are many different types of maps. You just select for example, this map. And now because our Power BI is going to get upgraded, so this map is not, the visual is not working, and you just have to add state to your thing. So now you see Delhi, Maharashtra, and Gujarat. You can see the maps. There are different types of maps also, and Power BI basically has an option like you can get more visuals. So when you go to this, get more visuals, this is not the only visuals you can play with. There you go, it will take you to a Microsoft Office store, and there you can just select whatever. So if you want to get a heat map or get any kind of visuals you want to show for your dashboard, which will hold your purpose for analysis, you can just add it over here and you can use those visuals for your analysis. So you all know how to make a column chart and stack chart. Now, when I was talking about measures, I can just show you all one measure which I created, for example, amount by vehicle. So this is what I mean by DAX. So here, this is basically you click on new measures. Here you will just put the formula which one, like simple Excel formulas also work. Here you are saying amount by vehicle. So you saying to calculate total amount, which I had created a measure called total amount in the same table, except for the fact tool in the by the get it by the fact toll plaza vehicle type. So it is basically telling you to calculate amount by the vehicle type, and this is your table names in that new measure. So this is how you can create a lot of 80-20 analysis you can do here. You can get a 90th percentile over here and create these measures, make it more complex, make the analysis more complex, which will give you a basic understanding to your get more business value can get out of it. And if you see, this is what I have done for my dashboard, which I had created. Here I'm using limited data, so that's why if you see the revenue trends are going a little bit down. But once you have a lot of data, there might be some data mismatch also. So you have to be very careful when you are cleaning the data. So in Power BI, the essential step is not visualizing the data. Yes, that's the important step. But if you mess up in your cleaning, so whatever you do in your visualization stage can have it has a huge effect. You might give out wrong information to the stakeholders. So your cleaning has to be proper. There should be no missing values. There should be all your data types should be proper. Your text should be text. Your numbers should be numbers. And if you're doing any adding new columns over there, then that should be proper. It should make sense basically. And then you can go through the making the graphs and the KPI cards, the slicers, and all of that. So this is, I would like to, and once you have done, you just publish it and you go to Power BI Cloud and you can download this dashboard in a PDF version or whatever, and you can make it a clickable link so that you can collaborate with your colleagues and your employees. So I would want to talk a little bit, just give you just a, I'm not going in depth with DAX because it is a little bit more advanced. We'll cover this in our next webinar. So DAX is basically a formula language of Power BI. It is what we use to build calculate measures like total, like I showed you all, total amount, average revenue per vehicle, and all of that. So we simply use DAX functions here, but in the next example, I will go a little bit advanced and show you all the year over year growth, the totals, the dynamic measures which we can create for DAX using DAX, and which will create a more powerful dashboard than rather a simple dashboard. So there's one question we often get from clients is like, where do we start? I would I would like to conclude my demo. I hope you all have a basic understanding how to go about your Power BI and how you can, what tools you all can use and what not to do. And this is a little bit helpful. So I'll just go to my PowerPoint. So this is what data structure for relationship, your data model I was talking about. And this is a visualization once the dashboard is created, how it can view and how you can share it with your colleagues and your stakeholders. So next is real world industry use cases. Get Vivek sir, if you can join in.
Yeah. So there's one question related to can we take this Power Dashboard on PowerPoint? So if you have the subscription, you can do that. The simple unpaid desktop version doesn't allow you. And there is within that ecosystem also you can share it, etc. Yeah, going to the okay, so we'll be looking at certain cases to understand how data analysis is applied to the logistics world, right? So let's look at the first case, your fleet maintenance here. Right now, when we talk about fleet maintenance, what typically happens, there is, as you would see with your cars, vehicles, etc., you do a scheduled service, right? But is the scheduled service proper? How is typically a scheduled service done? There is a certain, based on a certain assumption from the manufacturer or some expert, they'll tell you, every X kilometer, every Y years, every Y month, do a servicing, right? Is it required or not? Question number one. Question number two, does it solve the purpose, right? Am I paying the right cost by doing, doing a preventive scheduled maintenance? Am I getting a overall better utility of the vehicle over its lifetime? These are analytics which you would do, right? So you'll say, okay, what is, for instance, if I don't do maintenance, okay, or otherwise, how is my vehicle performance happening? If I'm not doing maintenance, I'm not changing my oil filter, grease, etc. Is the the fuel efficiency of the vehicle, for instance, truck, or is going down? So these are analytics which you can do. The data you'll pick up through various sources. It could be an IoT device, it could be a trip-wise data summary, etc., etc. And by taking it from bottom up, you could analyze those instances. What will be the business impact of it? Obviously, I mean, you'll know that your incidence mapping and your assumptions about incidents, your breakdown incidents, maintenance incidents, is realistic, right? When you say realistic, manufacturer when they prescribe you, they also tell you on certain realistic assumption, but their assumption is generalized, right? For instance, if you're a truck operator and your truck operates mostly in urban areas where they move in lower gear, your maintenance required will be different. If they do a lot of hill trips, for instance, their maintenance required will be different. If they're doing a lot of heavy loads, they're doing less loads, those would be variation. And what you're doing, if you're going by the prescribed norm, you are doing, you're maintaining it for all trucks a similar schedule. Does it make sense? To a certain extent, yes. Does it make sense totally? No. How does data analytics help you? By making it customized, understanding how to customize, understanding whether customization will make sense or not at all. So that is an instance. Let me go to the second one. Yeah. So port operations, right? Now, in port operations, typically what happens, you have the flow of containers, for instance. Let's take that, right? So there are congestions which happen. Generally, there is a peak and there is an ebb and so on. That flows happens. Now, remember that example we were talking about earlier as well. For instance, in the scheduling thing, how would you schedule, right? So you use your predictive model. You diagnose where is a problem happening. Before that, you also do a descriptive analysis to say, okay, in the month of September, in the month of October, in the month of August, July, so and such and such will happen. This year, last year, what is the variation, so on? What is the wait time average per month? How is it increasing? Is it increasing? Is it actually a problem? Okay. So those are the analysis which you'll do. Then you'll see, okay, where is the problem like? Is the problem happening in 1 month, every month, on some day, at some hour? So those are the analysis which you'll do. Basis that you'll have, identification of the problem and potential solutions. You'll do some level of, predictive analytics to see, okay, if given a certain addition, given a certain thing, if I change the rate here, what will happen in the end? So those are the analytics you do, and then you do a prescription analysis, which is basically you will take into consideration multiple factors and say, okay, fine, do X, Y, Z to get A, B, C. Going to the next one. Warehousing, similar thing, right? Scheduling. Now, typically in a warehouse, what happens? How much do you store? Where do you store? How much space do you allocate? Which one do you store near the gate? Which one do you store inside? Which one do you store up? Which one do you go down? Now, all of that could be dependent upon some general thumb rule. Okay, so when do you order? How much to dispatch, and so on and so forth. What typically happens is a lot of times, you would have heard of these terms called economic order quantity, minimum order quantity, safety stock. So these are typically thumb rule based things. Now, these are certain assumptions which have been, or thumb rules which have been developed basis certain business experiences over time, right? But as complexity grows, as requirement grows, a lot of these thumb rules are not very feasible. And therefore, you need to fine tune it to the business requirement of today and be ready for tomorrow. This is where data analytics help. Say, okay, history chart. What is a sales history? What is a movement history? Movement history by category, movement history by time, movement history by date, movement history by say the shift, morning shift, evening shift, right? What is the order time? What is the lead time, lag time? What is the processing time, etc., etc. So multiple variables come into place, which is what it becomes. And in a warehouse, typically, because your SKUs are multiple, sometimes the total units you'll be storing will be multiple. The transactions would go into millions. You may be dealing in boxes, for instance. You may be dealing in small pieces, for instance. So those situations will lead to complex things. Now, how would you do a proper scheduling? Typically, a broader and thing you would do is basically something called as an optimization. Say, okay, what is the best solution? Is there one single solution? No, mostly not. Right? It will be very difficult to arrive at the one perfect solution. So if one perfect solution is not available, what is the next option? Which is the most optimum solution, which means your most of your critical requirements are met. On others, you're at least crossing the threshold. So there you would add things like linear programming, for instance, which would be forming part of your prescriptive analysis to say, okay, let's schedule in this way, let's order in this way for items. There's typically you would have a lot of ABC analysis, saying certain priority items to be ordered on a regular basis, others on a less frequent basis, etc., etc. So those are things you would do in the using data analytics. Data is very important nowadays in warehousing optimization. It has gone beyond warehousing per se to look at supply chain. You're not just looking at one warehouse, you're looking at multiple warehouses, you're looking at production, transit, etc., etc. It has become so data intensive these days, the supply chain, that a simple desktop-based analytics is not sufficient. But still, for smaller models, particularly when working for smaller businesses, you could still use your desktop and whatever operations we have, things we have talked about. Next, please. Yeah, so Toll Plaza, the example which we talked about in great detail. What are the typical issues you will have? What are the questions you will have? Okay, is my operations good enough? Which means service standards are being maintained or not? Is my revenue realization fine? What typically happens, for instance, in toll plazas, you'll see a certain problem of revenue leakage. Now, revenue leakage would happen in two instances. One, that a vehicle is passing and is not tolled. That's one, and possibly a separate, an alternate route has been found, and therefore there's a revenue leakage happening. Now, these are insights which you could come from data. How would you come to know about it? Over a period of time, this is not happening. You'll see, okay, in this particular toll plaza, you have traffic, a certain traffic. In the following toll plaza, your traffic has gone, is up, whereas there is only one route which is bypassing your toll plaza and connecting to the following toll plaza. This gives you a sense. So this is how you do look at data and do data analytics. A lot of data analytics is common sense basically, but common sense with a lot of diligence and with the aid of a lot of analytics too. So when in logistics, the unique thing with logistics is that the number of transactions you will have will go into millions possibly. If you have say a nationwide business, you would be generating millions of records, data records, in 1 month, maybe possibly even in 1 week. So at the end of the day, you will have a lot of huge data, so which is where your big data analysis, your data lake, your data repositories, your reports, and so on will come into flow. But even for medium scale businesses, this could be utilized. It could be utilized even for small scale businesses. In our consulting businesses, how we utilize this, we do a lot of data analytics. We use a lot of Excel based tools as of now. The Power Query which you saw in Power BI is also available in Excel. Almost the same thing. But there are two advantages with Power BI. One, the DAX language which you saw offers greater flexibility. It's more easier to read. Now, Excel models, Excel formulas also have, there are a lot of transformations which have happened. For instance, there used to be a filter function in Power BI which was not available in Excel. That filter function is available in Excel now. The pivoting which you do, multiple table pivoting, that's available in Excel. So a lot of, even if you don't have Power BI access or you're not using it, for instance, a lot of this data analytics you can do in Excel. A lot of statistical tools are available in Excel. Also, you have these add-ins which are available in Excel. So those are also useful. But it's good to have some idea of Power BI. Similar to Power BI, there's a tool called Tableau. These are called as business intelligence tool. A very interesting thing about Power BI and why Power BI is useful is its ability to visualize at great efficiency. So as you saw, I mean, if I don't know if you got this perspective that Power BI is in a way combining Excel and PowerPoint. You have a slide where you are sliding data, doing your plots. You can also have inferences, text, etc. built in, add your inferences and so on. So all that combination at the speed and at the ease which you have is available in Power BI, which is a great tool. So if you're into consulting, if you're doing data analytics on your own side, you can at least download this. The Power BI file itself can be shared. If you can share a file, save a file on your desk and give it to somebody else, and they can open the file there, but you cannot collaborate on a real-time basis. So that's a problem. And if you don't have the paid subscription, if you have the paid subscription, then it's It's typically a per seat, per login, per registration kind of a thing. It will be useful. Obviously, there is a cost benefit analysis to that, but these are there. A lot of capability of Power BI also is there in Excel, and there are other tools which are available as well, which can do a lot of analytics for you on where you can do separate parts and separate tools. So that's there on that. Over to you, Priya. Any questions so far? You can just put in your chat, please. Can we automate the publishing? So you can automate. I mean, if you have that, for that, you basically require a subscription. And I don't know if you automate it per se typically, but it should be possible. It's not a very difficult task. Because now you have both Python and AI integration into Power BI. So you can set it to a calendar. You can do the updation and the the publishing or the sharing of the transaction or the report with others. Any further questions on this so far? You can keep putting it in the chat. Priya, over to you, please. You're on mute.
Yeah. So as Vivek sir was saying about Excel and Power BI, so these are basically a learning path in your data analysis thing. So you begin with Excel. So once you get familiarized with your Excel and your pivot tables, your Power Query, it is basically your half of your job is done when you're using Power BI. So it's just an advanced little bit version, but it's a combination of your Excel and your visualization. So this is, you start with your Excel, then get into SQL, where you can have a direct database management, because if you're working with large set of data, then SQL becomes more handy than using Excel. Then you connect it, as you saw, you can easily connect it to your Power BI. Now Python and R programming is just adds another layer to predict or simulate your analysis. And then cloud platforms are basically, then you move on to your cloud, where you upload your real-time dashboards, and where you can update, you can see your data. Once you update it in your Power BI, you can or your Tableau or anything, you can see the real-time dashboards are getting updated as well. And one additional part now, since AI has become a huge factor, AI ML has become huge in analytics. So it's like one of the more advanced levels, but machine learning and AI will help your career in analytics. It takes your career one step further than others. So for ML, there is a thing called orange data mining. So this is what will be our next learning in our next webinar. So this is why orange is, because it's an open source. It's easy. There is no coding required. You all don't need to know coding. It's just a drag and drop system for beginners and practitioners. It's very easy software. You can download it on your personal laptops, and you can just see those tutorial videos. But I will basically go into a more practical aspect with Orange. Here this means it is specially also, Orange is designed for, business users who want to explore machine learning, but don't have any coding knowledge or, data science knowledge to it, but it's a very hands-on thing. So we'll start here. You can work with a lot of models over here, like linear regression, logistic regression, clustering models. You can train your data on that, and you can see the the effect, the results of that on Orange. It's a very beautiful thing. Here also you can create the same what you're seeing in Power BI, those graphs and everything. Here you can also create those scatter plots, and you can analyze your data. So linear regression, when I say linear regression, is one part of ML. So basically it predicts future, for example, if I take a toll collection example, then it will predict your toll collections, or it will get your average revenue per vehicle. Where logistic regression comes in, it basically classifies the plazas, and which will like overperform or underperform in the upcoming month. It will predict that. Then if you see clustering, it will help you to group toll plazas with similar collection patterns and help identify segments and behave alike. So here your perspective analysis and predictive analysis will come in handy. Here you can just take your analysis to a very next step. So I'm going to help Orange will basically help us go beyond our dashboards, you can say. And here where Power BI basically tells us what happened, and why. Orange will basically help us estimate what is likely to happen also, and how we can plan for it. So it's in our next session, we'll just get an hands-on with Orange. We'll load our data set, build some models together. We'll compare how they can predict well in the real world, and that's it. So to wrap up today's session, we just started by understanding why data analytics is so important in transport logistics sector, not only there, but in every sector in our industries. We explored how data moves through different stages, from descriptive to diagnostic to predictive insights. And then I showed a mini demo on using Power BI. So I would like to, like, for the next section, we'll go in Orange data. And if there are any questions, I'll open the floor for any questions. If you all have, you want to ask us, you can just do that in the chat.
Yeah, there is a question from Mohit here. If I understand it, what you're saying is Microsoft from approval process linked to a database at Power BI. So if your data is real time, for instance, when you're saying automating it, what you're basically saying is, one is updation of data, second is updation of the report, right? Now, updation of data, typically wherever the data source is, the data is being collected, I would assume wahan par updation will happen on an automatic basis, right? The linkage, is it automatic or not? I mean, those options could also be done. The linkage could be there, but without a license, I'm not very sure what happens. We work more in the static environment where we look at periodic data. So because we get into depths of data rather than like a real-time dashboard or so on. So, but my sense is without a license, you're not going. You'll not have the automation, direct linkages between databases possible. All the database from which you are generating data and the database on which the tool on which you are analyzing the data and the tool on which you are publishing the data, you may, if you're wanting to do real time, you'll possibly need access to all, licensed access to all.
And also, Mohit, to add to Vivek, so like you are saying about can have some hands-on practice for regression analysis or using scatter plot. So yes, Power BI you can, but there's this Orange also you can do that, and it's much simpler to understand. So they already have your scatter plots ready. You just have to load your data set. They have already a training model for regression analysis. So you upload your data, you make a scatter plot, and you can then train that model using regression analysis. So I can, in Orange, for the next webinar, we can go in more depth on how regression analysis or logistic regression and all comes in play, and how you can train these models and how you can get the desired outcome from training these models. So it will touch upon your machine learning programs in that also.
Yeah. Regression analysis you can do even in Excel. I mean, see, it's basically a Y and an X plot, right? Y, suppose, is the output, X is the input. If you plot the data, if you have the data, basically, I mean, there's a formula. So based on X, the value of Y will come, right? And you will have the output. These will be multiple data points. If you put that on a scatter plot, you will see patterns of data emerging. It could be, sloping upwards, which is a positive correlation. Sloping downwards, which is a negative correlation, which it could be random, which means there is almost negligible correlation. It could be clustered, which means it is possibly something like a step function and may not be a straightforward simple linear regression, and so on and so forth. So that's how one could do it. I would suggest, I mean, there are Excel offers those demos as well, and you can start with a simple example to do it. Yes.
Yes. Any other
Any
questions?
further questions? You would get some demo about these models from Priya next time.
Yeah, so I was so these models which I'm talking for the orange data mining will give you more idea for the next webinar how it will be. So we will give you for more information once the more webinar is set up. So we'll go into the live aspect of it also.
Right, then can we then close the webinar? Okay.
Yeah, if there is no further question, then I would just like to thank you all for your time and your attention, and I hope you all found today's session useful and learned something practical, and you can apply it in your own work. So we'll be back soon with our next webinar on predictive modeling using orange data mining. So where we'll take this conversation to a next level. So thank you once again, and have a great day ahead.
Great. Good show, Priya. Yeah.